Hello everyone. In this video, we shall discuss the graphs of the six trigonometric functions and we identify their properties. But first, let us define what is meant by odd and even functions. So let f of x be a function, and we say that this function is an odd function if when f is evaluated at negative x, it's equal to the negative of f of x for all x in its domain. So for example, now the function f of x equals x cubed is an odd function. So if we will try to evaluate this function using negative x, we will be having negative x quantity raised to 3, and this is negative x times negative x times negative x, and that is going to be negative of x cubed. And we know that x cubed is our original function here, so which means that this is written as negative of f of x. And then second, this function is an even function if f of negative x is equal to f of x for all x in its domain. So an example of this would be the function x to the fourth is an even function because if we evaluate f of negative x using this function, we have the quantity of negative x raised to 4, and this is negative x times negative x times negative x times negative x, which is positive x to the fourth. And x to the fourth is our original function, which is f of x. So therefore, f of negative x is equal to f of x. That's why f of x equals x to the fourth is an even function. Now let's proceed with the graph of the first trigonometric function, which is the sine function. So let's consider the function y is equal to sine x. So using values of x from 0 up to 2 pi, substituting them into this function will give us the following y values. So if we get sine of 0, it is 0. Sine of pi over 6 is 1 half. Sine of pi over 4 is square root of 2 over 2, and so on and so forth. So if we're going to plot these points, this point is 0, comma 0. This point here is pi over 2, comma 1. This point here is pi, comma 0. And then this point here is 3 pi over 2, comma negative 1. And this point is 2 pi, comma 0. So this is the graph of the sine function, and actually it extends indefinitely to the right side and to the left side. So if we only consider this part of the graph, now we can say that this graph of sine x repeats not to the right and to the left continuously. Okay, so to get its properties, let's determine the domain of the sine function. So in domain, the domain of this sine function is the set of all real numbers because the graph extends indefinitely to the left and to the right side. So that means the domain is the set of all real numbers x. Now for the range, if we look at the y-axis, only the values in this interval are covered by the graph. So which means that the range is the set or the interval where y is between negative 1 or where y is from negative 1 up to positive 1. So we can write this as the interval from negative 1 to 1, and they are closed with square brackets. Now the domain can also be written as negative infinity, comma, positive infinity, and they are enclosed inside braces. Now the third property here is we can say that y equals sine x is periodic. So this means that the graph repeats its pattern every 2 pi. And hence, 2 pi is said to be the period of y is equal to sine x. So if we go back into the graph, every 2 pi units, the graph will repeat. So this interval here is from 2 pi to 4 pi, and then from 4 pi to 6 pi, we have another copy of this graph. Now in the negative part of the x-axis, from negative 2 pi up to 0, from negative 4 pi up to negative 2 pi, the graph will just repeat. And then the x-intercept happens at the points k pi comma 0, where k is any integer. So which means that the x-intercepts would happen at pi, 2 pi, 3 pi, 4 pi, 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and so on and so forth. So to illustrate this in the graph, these are the x-intercepts. So it happens at 0, at pi, 2 pi. We have negative pi, negative 2 pi. Now for the y-intercept, the graph crosses the origin, which is also the y-intercept of the sine function. So this is the y-intercept. And then the sine function doesn't have any vertical or horizontal asymptotes, and it's an odd function. So it means that sine of negative x is equal to the negative of sine x. So you can verify this using any angle x. So if you have sine of negative pi over 4, then it must be equal to the negative of sine pi over 4. And then the graph of y equals sine x is symmetric with respect to the origin. So which means that if we're going to fold this graph along the y-axis, and then if we fold it again along the x-axis, the graph will just overlap. Okay, next is the graph of the cosine function. So similar to the sine function, we can generate this table of values by substituting x from 0 up to 2 pi and determining the values of y as follows. And then we can plot these ordered pairs on the Cartesian plane, and then we get this graph of cosine x. So if you notice, this ordered pair is 0, comma 1, which is this point. This point is pi over 2 comma 0. This point, this ordered pair is pi comma negative 1. And then this ordered pair is 3 pi over 2 comma 0. And this ordered pair is 2 pi comma 1. So just like the graph of the sine function, this extends indefinitely to the right side and indefinitely to the left side. So which means that the domain of the cosine function is the set of all real numbers, or in interval notation, we write it as negative infinity up to positive infinity. So just like the sine function, the range is y is from negative 1 to positive 1 because the graph of the cosine function covers only the following interval. So from negative 1 up to positive 1. So also, the graph of cosine function is periodic with a period of 2 pi. So which means that the graph of the cosine function will repeat every 2 pi units. So as you can see from this graph, from 0 to 2 pi, we have this pattern of the graph. And then from negative 2 pi to 0, we also have the same pattern of the graph. Okay, and then the x-intercept of cosine function happens at k pi over 2 comma 0, where k is an odd integer. So this means that if k is equal to 1, the x-intercept will happen at pi over 2 comma 0. It can happen at 3 pi over 2 comma 0. It can happen at negative pi over 2 comma 0. It can happen at negative 3 pi over 2 comma 0. So going back into the graph, so this is an x-intercept. It happens at pi over 2. It happens at 3 pi over 2. It happens at negative pi over 2. And it happens at negative 3 pi over 2. And so on and so forth. And then the y-intercept is the point 0, comma 1. So as you can see, the graph of the cosine function crosses the y-axis at 0, comma 1. So similar to sine function, there's no vertical and horizontal asymptote for cosine x. And cosine x is an even function. So which means that cosine of negative x is equal to cosine of x. And the graph of the cosine function is symmetric with respect to the y-axis. So which means that if we fold the graph along the y-axis, the graph will just overlap. Now, for the other four trigonometric functions, we will just show the graph here, but we will not anymore obtain the table of values. So here is the graph of y is equal to tangent of x. So this graph here, each copy of the graph extends indefinitely upward and downward. Okay, so this is like, so it actually repeats, so it's also periodic, just like the other two trigonometric functions. So for the properties of tangent x, its domain is the set of all x values except on the following lines, no? The broken lines. So the broken lines happen at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2, and so on. And these broken lines are called the vertical asymptotes of the tangent function. So which means the domain is the set of all x values except those that are k pi over 2, where k is an odd integer. And these k pi over 2, the vertical asymptote happens at these angles or at this value of k pi over 2. So therefore, the vertical asymptote is x equals pi over 2. Actually, there are a lot of vertical asymptotes. Okay, but k, of course, is an odd integer. And then if we look at the graph of the tangent function, since the graph extends indefinitely upward and downward, therefore it covers all the values on the y-axis. So which means that the range of the tangent function is the set of all real numbers or the interval from negative infinity to positive infinity. Now for the period of tangent, so the from the graph of the tangent function, the graph or the pattern repeats every pi units. So this one is pi units, this one is pi units, this one is pi units, and so on and so forth. So the tangent function is periodic with period pi. And then the x-intercept happens at negative 2 pi, negative pi, 0, pi, and 2 pi. So in general, the x-intercept happens at k pi, comma 0, where k is any integer. And then the graph crosses the origin. So definitely the y-intercept is also the origin, 0, comma 0. Now the tangent function doesn't have a horizontal asymptote, and it is an odd function, which means that tangent of negative x is equal to the negative of tangent x. And it is symmetric with respect to the origin because if we fold the graph along the y-axis and then followed by a fold at the x-axis, the graph will just overlap. Now for the cotangent function, the graph cotangent function is like a reflection of the graph of the tangent function. And it's also extending indefinitely upward and downward. So for the domain of this function, the domain is the set of all x values except those at the vertical asymptotes. And the vertical asymptotes happen at negative 2 pi, negative pi. This one is also a vertical asymptote at 0, at pi, and at 2 pi. So therefore, the domain is the set of all x such that x is not equal to k pi, where k is an integer. And since the graph extends indefinitely upward and downward, the range will be the set of all real numbers. So just like the tangent function, it is periodic with period pi because the graph repeats every pi units. Now for the x-intercept and y-intercept, x-intercept happens at k pi over 2 comma 0, where k is an odd integer. So which means that this one is an x-intercept. So it happens at negative 3 pi over 2. It happens at negative pi over 2. It happens at pi over 2. It happens at 3 pi over 2, and so on and so forth. And then there's no y-intercept because the graph does not intersect the y-axis. So there's no y-intercept. And then for the vertical asymptotes, it happens at k pi, where k is an integer. And also, just like the tangent function, the cotangent function doesn't have any horizontal asymptote, and it's an odd function, so which means that cotangent of negative x is equal to the negative of cotangent x. And it is symmetric with respect to the origin. So which means if we fold the graph along the y-axis and then followed by a fold on the x-axis, the graph will just overlap. Okay, next is the secant function. So here is the graph of y equals secant x. Actually, the graph of secant x is based on the graph of the cosine function, since secant is just the reciprocal of the cosine function. If this is the graph of the cosine function, then the graph of the secant function will be reflected along y equals 1 and y equals -1. Okay, so it's extending above, extending below, but it doesn't have any y value between -1 and 1. So for the domain of the secant function, the domain is the set of all x values that are not equal to k pi over 2, because k pi over 2 serves as the vertical asymptote of the secant function. And then its range is the set of all y values except the interval between -1 and 1. So that's why its range is written as y is lesser than -1. So which means that uh, the graph of secant occurs below -1, and also it is y is greater than or equal to this should be positive. Y is greater than or equal to +1. That's why the graph occurs at above the line y equals 1. And it's also periodic with period 2 pi. So which means that the graph of secant function repeats every 2 pi units. So if this is 2 pi units, therefore, in the next 2 pi units, this graph or this pattern will just repeat. And then observe that since there's no value between -1 to 1, there's no x-intercept for the secant function. So x-intercept none, y-intercept, it crosses the y-axis at this point at 0, 1. And then it has the vertical asymptotes at k pi over 2. It doesn't have a horizontal asymptote. And just like the cosine function, it's an even function, which means that secant of -x is equal to secant of x. And it is symmetric with respect to the y-axis. So which means if we fold the graph along the y-axis, the graph will just overlap. And then finally, for the cosecant function, so this is actually similar to the secant function, and the cosecant function is actually based on the graph of the sine function. So it's the reciprocal of the sine function. So for the domain of cosecant function, it's the set of all x values except at the vertical asymptotes. And the vertical asymptotes happen at -2 pi, -pi, 0, pi, and 2 pi. So that means the domain is x is not equal to k pi. The vertical asymptote is x is equal to k pi, where k is an integer. So just like the secant function, its range is y is less than or equal to -1, or y is greater than or equal to +1. And it's periodic with period 2 pi, and it doesn't have any intercepts. So if we go back here, there's no x-intercept, there's also no y-intercept. And it doesn't have any horizontal asymptote, and it's an odd function, which means that cosecant of -x is equal to the negative of cosecant x. And it is symmetric with respect to the origin, which means that if we fold the graph along the y-axis and then followed by a fold on the x-axis, the graph will just overlap. So this ends our video about the graphs of the six trigonometric functions and its properties. There will be a separate video for the discussion of graphs of the sine and cosine function that involves shifting of points. So thank you for listening, and I hope that you learned something from this video. And please do not forget to subscribe to my channel. Thank you again.